Okay, so some brave wildlife biologist is tracking a polar bear. Okay, they travel 300 meters south, then 550 meters at 75 degrees north of east. We're looking for their overall displacement. This question is important because this is exactly the kind of question you'll get on your unit exam. One vector that is along a major compass direction and one that is angled. Okay, this one won't take you as long as number 2 because there's less calculating to do. And you don't have as many x's and y's to solve for in this one because one of your vectors is due south. Okay? So I'll give you a couple minutes to get the diagram and then I'll draw it. So our diagram for this, our first vector is 300 meters south. Scale is really important on this diagram. Okay? Scale is really, really important. In fact, I need to move this down a little bit so that I can fit this actually on here. All right, so that line is 300 meters and it's due south. Okay? The next vector is 75 degrees north of east. Okay? So I'm actually going to move my 300 over to the other side of the line just so it's not going to get in the way. Okay, 300 meters. Okay, now 75 degrees north of east. So here's due east. And I've got to go 75 degrees north of that. Okay, which means it's a pretty small triangle. Maybe not quite that small, but pretty small. And I'm going to go 500 meters along that vector. Am I going to get past where I started? I think so. Okay, I don't know that for sure because I haven't done the math yet. But I'm pretty sure that if there's only a 15-degree difference in the direction, but a 200-meter difference in the length, okay, actually 250-meter difference in the length, then I'm going to get well past where I started. I mean, really, this second line is almost twice as long as the first. Everybody with me there? Okay? In fact, I'm really feeling like I should probably shorten this line just a little bit so I can actually fit this on the screen. Okay, so 550 meters is obviously quite a bit longer than 300. So I'm going to draw it kind of like that. Okay, so this is 75 degrees. This would be y, this would be x, and this is 550 meters in length. Okay, that means my resultant goes from my initial position to my final position. Okay, so my diagram should look something like that. Obviously, you could have drawn the triangle over here as well, okay, if you wanted to. There's nothing wrong with that. I just don't like to overlap my lines if I don't have to. Okay. All right, keep going on that one, guys. Got some X's and Y's to find. Okay, let's have a look at a few of the other numbers here involved. If I want to find the X and Y components of the 300 meters south vector, okay, I don't have to do any math. I just have to recognize that it goes due south. So its X component or horizontal component is 0 meters. It doesn't go east or west. Okay, so that one's done. Okay, and the Y component is 300 meters south because all it does is go south. Everyone okay with that? Right, so really no math required for that part. For the red triangle, I do have to do a little bit of math. Okay, X is adjacent to that 75-degree angle, so it'll be the cos of 75 times 550. Just like we learned yesterday. All right, so cos of 75 times 550 is going to give me 142. East, okay, and my Y component is the opposite side, so it would be the sine of 75 times 550. Okay, so we're looking at 531 there. so now that I have all the x's and all the y's, can I find the sides of my resultant triangle, the blue one? Okay, so this thing from an x perspective only goes east, and it only goes 142.35 meters east, okay? Because there's nothing else to add, right? So blue x is equal to red x because black x is 0, right? So we got 142.350, blah, blah, blah. Okay, I'm not going to write them all, okay? But I'll keep them in the calculator. Okay, and then to get blue y, I've got 300 meters south, and I've got 531 meters north. So he ends up going north, how far? She ends up going north, how far? $231.25 meters, right? She went 300 south and then went 531 north. She ends up 231 north. Agreed? Okay, so when we're doing that subtraction there, okay, we would just do basically negative 300 plus 531, okay, and we would get our 231.259, whoop, 259, et cetera, et cetera. Okay, and that's meters north. Okay, so can I now, what's my next step? I have the two sides of my overall displacement triangle. How will I find my overall displacement? Do Pythagorean theorem, okay? I have y and x, and I'm looking for d. Okay, so my next step is to take the square root of a squared, that's the 142, okay, plus b squared, 231. So, in our calculator, that's going to look like this. 142.3504748 squared plus 231.2592045 squared. Okay, so my overall displacement's 271.55. We have two significant figures here, so their answer is actually incorrect here. Okay, so we have two significant figures, so that will mean 2.7 times 10 to the 2 meters. Okay, so that's the magnitude. What else do I need to find? I need to find the angle, right? Displacement's a vector quantity, has magnitude and direction. Okay, so to get theta, I'm going to go tan to the minus 1 of my opposite side, which was x, so that'll be the 142 point whatever, divided by y, which is the 231 point whatever. Okay, and we'll put all those numbers in. So second tan of 142.3504748 divided by 231.259205. All right, so we're getting 32 degrees here. Okay. Okay, and for me, that's 32 degrees which way? My angle arc is touching due north, and I'm going east of north. Okay, so my angle's east of north. Their angle is the complementary angle, 52 degrees north of east. So if you do the triangle the other way, which is what they did, okay, they drew their triangle like this. They got all the same numbers as us, but they're going to reference east instead of north and get the complementary angle that we did. Okay? All right, is that ringing a bell? Now that one was a lot faster, wasn't it? Because there's basically half as many calculations. You didn't have to find x and y for the black line. Okay, so it goes faster because you don't have to have as much stuff to do. Okay, are we kind of getting the hang of this? It's all the same steps. Now it's just a matter of repetition and practice so that we can make those steps faster. Right? Okay. angles. All right, I want you guys to try this one, okay? I want you to draw it, I want you to find X's and Y's, okay? So the combine is harvesting the field. It first moves 950 meters, 30 degrees north of west, then turns and travels 385 meters, 45 degrees south of east. Okay, so these two lines really backtrack on each other, so scale's important, okay? There's a second part to it. If the whole trip takes 540 seconds, what's the average velocity of the combine? If you're going to find average velocity, what do you need first? Displacement. Okay? They give you the time, so you've got a vector addition question to get the displacement, and then a simple v equals d over t question after that. All right, give you some time on that one. All right, I'm just going to put the diagram up here, guys, so you can see if you did the drawing correctly. Okay, so we've got 950 meters, 30 degrees north of west. Okay, so I'm going to draw a reference line that's west. Okay, I'm going to go 30 degrees north of that. Maybe a little less than 30 degrees, but I think it'll be close enough. Okay, and it is 950 meters long. Okay, my next line is 385 meters long, so much shorter. Okay, 45 degrees south of east. All right, so there's my reference line due east. I'm going to go 45 degrees south of east. Okay, so this angle here would be 30 degrees. Everybody okay with that? Okay, so I need to go a little bit south of that. Okay, just in terms of scale. Oop, that's not very straight. Okay, something like that. They're really backtracking over each other right now. Okay, 385 meters. This angle would be 45 degrees. Here's X, here's Y. Okay, here's X and Y for the black triangle. Okay, and then we've got, oh man, I'm struggling with my straight lines here today. Okay. There's our result. How crowded is this? Very. It happens sometimes. When you got a lot of backtracking over itself, your diagram's going to get kind of busy and crowded. Okay, and that's all right. But that's what we should be looking at. All right. A lot of people make the mistake of drawing this 385 so that it goes way too far down. Okay, things like that. Again, this is where scale is really important in your drawing. If you make that line too long or the angle's too far off, then your diagram is going to be wrong. Your math won't lie to you. You'll get all the math right, and then you'll look at your picture and go, oh, I must have screwed up the math. And it was exactly what we were talking about the first and second days of this. Right? The diagram is crucial. Okay. So that's what we've got so far. Okay, we've calculated all the x's and all the y's. Okay, and now we're going to calculate our overall displacement using Pythagorean theorem, and it's going to come out to 550.488.0228 squared plus our answer squared, because that's quicker. All right, so our overall displacement is 586 meters, and how many sig digs do we have here? We have 2 only. Okay, so it's going to be 5.9 times 10 to the 2 meters. Actually, we're not done yet. I need to keep all those decimals. Why do I need to keep all those decimals? Well, not just for the angle, but I have one more calculation to do after this to actually arrive at my final answer, so I can't round off yet. Okay, so this will be 586.643219 meters. Okay, I also have to find the angle. Why do I need to find the angle if I'm looking for velocity? Velocity a vector quantity? It is, okay? Think back, I know this is a long time ago, but think back like the second day when we did that example where you walked to Walmart and back, okay? your vector for your displacement and your vector for your velocity are always the same. They're talking about the same trip after all. All right, so your whatever your displacement's vector is, that's what your velocity's vector will be as well. Okay? So theta is going to be tan to the -1, okay, or whatever trig function you want to use. For me, it's going to be y over x because of the way I've drawn the triangle. So that'll be 202 over the 550. That'll give me my angle. Okay, divided by 550.488022. All right, so I'm getting an angle here of 20 degrees, okay? And I'm going to put that one in the proper number of sig digs because I won't need to use it for a calculation again, so just 20 degrees. Okay, which way is that? Okay, so my triangle goes like this, it goes this way, okay? My angle arc is touching due west and going north of it, okay? North of west. Okay, so now I've got the displacement, I've got its direction, but they want velocity. Okay, average velocity is total displacement over total time. Here's my total displacement, 586 meters, with all the decimals, obviously. Okay, and they tell me that that takes 540 seconds. All right, so 586 over 540 will give me the magnitude of my average velocity. So 586.643219 divided by 540. Okay, so we're looking at two significant digits here, 1.1 meters per second at 20 degrees north of west. You could also have 70 degrees west of north, and that would also be acceptable. Okay, everybody with me there? That is as long and as involved, really, as a two-vector problem can get, right? I will at some point give you a 3 or 4 vector problem. It doesn't make it any more difficult, it just makes it take longer because you have that many more x's and y's to calculate, okay? But the steps are always the same. Draw the diagram. Find all the x and y components. Add the x's, add the y's, do Pythagorean theorem, get the angle, done. Okay? Always the same steps, okay? All that changes is how many x's and y's do you have. All right. Try some easy ones. These ones are super easy. Like some of these are collinear. Like the first one. You can do that one in your head. Okay? So I'll go easy on you here for the rest of the class. Do these ones. Okay? They do get a little bit, they become perpendicular and then, okay, but they're not terrible. Okay?